What do you got there, Miss Shunky?
Ooh, got me some coffee.
Oh, I do too. It's so good.
I know.
Especially on a day like today when it's really, really cold
Yes.
outside.
Are you a big coffee drinker?
Well, I am when I'm in Brazil. They have the greatest coffee. I absolutely love it. But
That sounds pretty good.
yeah.
I like to have a little coffee with my cream and sugar.
Yeah?
Yeah.
I'm that way. I
You know
drink
what I
it
mean?
really, really sweet.
Not a huge coffee drinker, but I do like it every once in a while when it's cold and you want to warm up, but I really have to put a lot of stuff in there to kind of
Yeah.
dilute it down some.
Some people drink it black, where, it pours out and it's just like dripping, very viscous
Yeah.
and so thick.
Ugh, yuck.
That's way too concentrated for me.
Me too.
Personally, I like to really dilute my coffee with lots of cream and lots of sugar.
Me
Sugar
too.
doesn't dilute it, but the cream does.
Yes, very much so.
We're gonna be
Well,
talking-
hey, guess what?
We're talking about dilutions.
We are talking about dilutions today.
I like strong
What a
coffee, but
coinkydink.
we really dilute it. Yep.
Yes.
It is a coinkydink.
Well, let's talk about dilutions. Vodcast 10-6.
Alrighty.
And 10-6. And maybe...
Oh dear.
You
There
know
it
when
went.
this happens. There we
All
go.
right.
Oh, okay, there we go.
Alright, so we're going to be talking about which of these two beakers is more concentrated and which one's more diluted.
Yep.
Dilution is the process of making a less concentrated solution.
There you go.
This is usually done by adding more solvent to the solution. Now, solvent being the thing in higher quantity,
Right.
the solute being a thing in lesser quantity.
Right. So I have this background picture here that kind of helps illustrate this.
Right.
When you look at these two beakers, which one do you think would be more concentrated?
Well, the one that has less solvent.
Right. There's actually the same number of particles in each of these, but this one
And you can count
here
them
on this
if you
side
want.
has a lot less solvent in there.
Mm-hmm.
This one is therefore more
Diluted.
dilute
That
because there's a
one's
lot
definitely
more
more
solvent in this one.
That's
Same
like my
number of
coffee.
particles. Yeah.
Yeah.
All the cream and everything
All the
mixed in
cream,
there.
yeah. Diluted.
I like it that way too.
Yes, so much better.
Most certainly.
All right.
All right.
So, we usually use molarity in dilution problems as it is the most common way to express concentration. Right? We learned about that last video.
Yep.
When we add more solvent, we are decreasing the concentration of the solution,
Yes.
which decreases the molarity of the solution and makes the solution more diluted.
Very good. And vice versa.
Right.
If we were to somehow remove solvent, although you'd have to
You
find
could do
a
that
special way to do that.
You could do that by
React it or
evaporating
something.
water out.
Yes, that's true. You
But-
could evaporate.
You do sometimes lose some of your solvent that way.
Yep.
But anyway.
All right.
All right. So most of the time we are diluting. It's
Yes.
much more difficult to make it more concentrated.
Yes,
Now
most
we know
definitely.
that some people have been able to do that. They see that when they have a cup of salt water, and they drink it. It's not too salty, and then they leave it sitting in a hot place, and that water evaporates out, and then they go back to drink it again, and it's really, really salty.
Right. And
I know.
the thing about that is you can't control either the amount that you lose. So
Right.
yeah.
You can calculate it, but you can't
Yes.
control it.
This is true.
So you can't make the perfect concentration on purpose.
Not unless you do a dilution and
Right.
go the other way. Yeah.
Right. All right.
Let's talk about how to do that.
Okay.
Guess what? Another math problem.
Yay!
Okay.
What is the molarity of a solution of ammonium chloride prepared by diluting 50 milliliters of 0.379 molar
3.79 molar.
ammonium chloride solution into 2 liters? So we're trying to get 2 liters of solution, and we
Yes.
want to know what concentration that is.
Right.
So we have a handy-dandy
that
formula. V1 times M1 equals V2 times N2.
Right here.
So what we're starting with is 50 milliliters of 3.79 molar. So that's going to be our V1 and our M1, but we can't use milliliters. We have to convert it to liters.
Right, because this is liters right here. Now, if both of these were milliliters, we could go ahead and do it.
We
But
would
since
be good.
this is liters, yes, you got to convert that one. So we'll start by saying 0.05000.
Now remember, to convert from milliliters to liters, you just move the decimal place 3 places to the left Or the surefire way to double check is to divide by 1,000.
Divide by 1,000.
All right, and we'll multiply that by our M1, which is 3.79 molar. And we're looking for M2.
So we'll put our 2 liters in,
which is our V2.
and that's
then our
times M2.
Now to get M2 by itself, we do a little bit of algebra and we divide both sides by liters, 2 liters. Now the 2 liters cancels out on the right, and we're left with 0.05 times 3.79 divided by 2. And when we plug that all into our handy-dandy calculator, we get 0.0948 molar. Now that's a weird molarity. Usually we go to 1 molar or 0.5 molar, or but now we know exactly what our molarity is for the solution.
There you go.
All right. Not
Pretty
so bad.
easy. That's so stinking easy.
Yes, so much better.
Next one.
All right. A 1 liter of 3.8 molar solutions of iron sulfate, has 7 liters of water poured into it. Wow, that's a lot. You know, you think of those 1 liter bottles. They really diluted
a lot of it.
All right. What is the molarity of the new diluted solution? All right, so they give us a volume and a molarity, and now we want to find molarity again. So they give us 1, and hey, we don't have to convert because liters is...
It's already both in liters, right.
All right.
There is something tricky in this one, though. They got to watch.
Right, because we start with, and then we add 7.
Right.
We have 1, and then we add 7. So our V2 isn't just 7.
Nope.
It isn't just the number that they give us.
Nope.
Can't make it easy.
Nope.
We do 1 plus 7 because we had 1 liter, and then we put 7 more. So we have a total of 8.
8 liters.
Right.
Yep.
And now we're finding the second molarity. And we do the same thing, divide both sides by 8 liters to get moles by molarity by itself. And when we plug that into our handy-dandy calculator, we get 0.48 molar.
And one way that they can always check their calculations is if they know if the volume is getting bigger, then their molarity should get smaller. So if they get a number that's bigger than their starting molarity, they know they've done something wrong.
Right.
So sometimes when you get these calculations, they may say you started with this concentration, you have a starting concentration, and your new volume and new concentration is this, and they may have to calculate what their starting volume was.
Right.
Same formula, just, you know, finding different values. So. Wow, that was quick. And just in time for the principal to make an announcement.
Absolutely.
Enjoy this podcast. Bye.
A little bit long in the gym. We had planned